Okay, so today I'm going to show you how to do number 28 from chapter 6. So the question says a 7-gram bullet is fired into a 1.5 kilogram ballistic pendulum. The bullet emerges from the block with a speed of 200 meters per second, and the block rises to a maximum height of 12 centimeters. Find the initial speed of the bullet. So here I've drawn us a before and after picture of the situation. So here the bullet, which is 0.007 kilograms, I just did a simple conversion, is traveling towards the ballistic pendulum, which is 1.5 kilograms. And the ballistic pendulum is at a height of 0. I made it a height of 0. And the positive x and y axes I've labeled. And to make our work make sense, I labeled the bullet as object 1 and the ballistic pendulum as object 2. And so then after the bullet has struck the ballistic pendulum, it has gone through the ballistic pendulum and is traveling at 200 meters per second. And the ballistic pendulum is raised at a maximum height of 0.12 meters, which again is just a simple conversion from the 12 centimeters they give us. So we're supposed to find the initial speed of the bullet. So to do that, I'm first going to start by doing conservation of momentum. So conservation of momentum states that the initial momentum is equal to the final momentum. So the initial momentum of the system is the mass of object 1 plus the velocity initial of times the velocity initial of object 1, and plus you would usually do the mass of object 2 and the velocity initial of object 2, but in this case there's no velocity in object 2, so that part is lost, equals the mass of object 1 times the velocity final of object 1 plus the mass of object 2 times the velocity final of object 2. So now we just fill in our known values, 0.007 kilograms times the velocity initial of object 1, the bullet is what we're trying to find, equals the mass of object 1 times the velocity final, which was given to us, 200 meters per second, plus the mass of object 2, 1.5 kilograms, times the velocity of object 2, which we also don't know. So we can simplify a little bit here. If you put it into your calculator, you get 1.4 plus 1.5 velocity final. So now we realize that we have two variables that we need to find. So to find the second variable, I'm going to find the velocity final of the ballistic pendulum. So we're going to go back to last chapter and use the conservation of energy. So in the conservation of energy, we learned that the kinetic energy, not the kinetic energy, just in general, the energy initial equals the energy final. So if we're looking at specifically the ballistic pendulum, in the beginning, the velocity is 0, so the only energy we have here is gravitational potential energy, and here we have both kinetic and gravitational potential. So this is the formula for gravitational potential, and this is the formula for kinetic, as you remember, but then we realize that this is at height of 0, so that just turns into 0. And here we just plug in the numbers, 1.5 kilograms, negative 9.8 meters per second. It's at a height of 0.12 meters plus 1/2, 1.5 kilograms, and the velocity is what we are trying to find. So with using your calculator, a little bit of rearrangement, we get to this step, and then from there you can solve to find your velocity is 1.53 meters per second. So this is the velocity object 2 final, I should say, and that goes for these things as well. So this is the final velocity of our ballistic pendulum. So now we can put this value back into the conservation of momentum equation. So 0.007 kilograms, velocity 1 initial equals 1.4 plus 1.5 times 1.53 meters per second. And from there, if you put that all into your calculator and isolate the velocity initial of 1, you get 527.86 meters per second. So that seems like a pretty big number. When I saw this, I thought that's a pretty big number, but if you look back into what was given, that actually makes sense, because if the bullet has to be traveling at a higher velocity than what comes out, because it hits the ballistic pendulum and loses some of its velocity and speed. So this answer makes sense. Okay, thank you.